This project is sponsored by PCBWay. Don't miss the PCBWay Christmas big sales from November 28th to December 31st. Get free Christmas coupons and redeem or check value a promo code. You can also start with PCB order for only $5. Up to 50% off for 3D printing and CNC machining and special sales in PCBWay stores. PCBWay has all the services to create your own project at the best price. Hello, in several of my previous projects I have presented ways to make weather stations, but this time I decided to make a specialized device with a strictly defined purpose. Namely, at least in my experience, the basic weather information for planning and activity in the coming days is whether there is a chance of rainfall in that period. Unfortunately, in commercial and most do-it-yourself weather stations, this information is either not available at all or is quite brief in the form of a current daily rainfall forecast. That's why this time I decided to create a specialized weather station with the purpose of providing detailed information about the possibility of precipitation in the current day and next 5 days. For this purpose, data from OpenWeatherMap site is used, where you can create a free API key. The display shows the predicted amount of precipitation in millimeters, the time of the day in which it is predicted, as well as the percentage probability of rain on a specific day. At first glance, you can see that I didn't pay special attention to the visual part of the display, in the sense that there are no advanced graphic shapes and images, but only rectangles that represents the days, so the required information can be determined very fast and easily. Specifically in this project, I used the Crow panel ESP32 4.2-inch e-paper display module with built-in ESP32 S3 microcontroller unit. It is very practical in the sense that there is no need to connect components and solder, and it has multiple input-output ports, a micro SD card slot, then multiple buttons, and even a battery charger circuit. Now let's explain how it works and describe the information displayed on the screen. In the upper left part of the screen, there is a basic information about the current weather. In the first line, we have descriptive information about the weather conditions, then the temperature in degrees Celsius with 1 decimal place, when the air pressure value and the air humidity expressed in percents. Next we have the label UT, that means which tells us what time the data was downloaded. Update time in my case is 8 AM. In the upper right part there is a space where the current situation regarding rainfall is indicated, as well as the forecast until the end of the current day. The space is divided by horizontal and vertical dashed lines. The vertical ones shows the time, 24 hours, midnight, 6 AM, noon, 6 PM and midnight again. The horizontal lines serve for a more precise orientation of the predicted rainfall amount in millimeters. The numbers on the left edge show the value of these parameters. It is very important to emphasize that for better visibility, this value is variable and depends on the maximum amount of precipitation in the 3-hour period, which is predicted for current day. So, as I mentioned, the amount of precipitation is predicted at a distance of 3 hours, and this is expressed through vertical bars. At the top is the day of the week, as well as POP symbol, which in translation means probability of precipitation and is indicated in percentage. The lower half of the display contains the forecast for the next 5 days of the week. Analogous to the previous description, the day is indicated at the top and the POP value in percentage at the bottom. The amount of precipitation is expressed on the far left, but now the maximum value is dynamically adjusted depending on the maximum predicted amount of precipitation through the next 5 days. Now in this case, each day is divided by the 3 horizontal and 1 vertical dashed line. The horizontal line serves for a more precise visual assessment of the amount of precipitation, and the vertical line indicates the time: midnight, noon, midnight again. As before, precipitation is presented graphically with vertical bars. With the free API key from OpenWeatherMap, we get precipitation data with a resolution of 3 hours. If no precipitation is predicted for a particular day, then the message "no rain" appears in the middle of the rectangle indicates the particular day. Now a few words about the code and some settings in it. Before uploading it, we need to enter certain data into the code. First, we need to enter the credentials of the local Wi-Fi network. I specifically use the device in 2 places with different Wi-Fi networks, so in order to not change the credential constantly, I made this part of the code in a way that the data from the 2 available networks is entered and the device connects to the currently available Wi-Fi network. In fact, this is a very practical option and you can enter any number of wireless networks. Then we enter a previously generated API key for the specific location from the OpenWeatherMap site, as well as the coordinates latitude and longitude for current place. Also, in void sync time function, in the config timeline, we need to enter a difference between UTC and local time in seconds. For my location, local time is UTC plus 2 hours, so I put 7,200 seconds. I create separate function for each part of the screen so the code is easily understood and customizable, so we can change multiple parameters such the width of the bars, imperial of metric units, font and other things. During the testing, I noticed that the readability of the display in a poorly lit room improves if the colors on the screen are inverted. For this reason, I added an option for inverted colors negative by pressing a button on the device. Now, when refreshing the screen, updating, the color scheme does not change. You can go back to the standard color scheme again by pressing the button. The device is currently set to check for new data on OpenWeatherMaps every 15 minutes, and this can be easily changed at the end of the code, and then goes into the so-called deep sleep mode. In this mode, the consumption is almost zero. In this way, the battery lasts an exceptionally long time, which is one of the positive features of e-paper displays. If for some reason the data from OpenWeatherMaps is not downloaded, all data is zero and -1 appears on the current weather screen in UT, which is a sign of an unsuccessful download. The data will be downloaded in next 15 minutes automatically or immediately if we press the reset button or the on-off switch.